Okay, here we go. We're going to start section 2.6 titled Rational Functions. All right, we'll start by finding the domain of these rational functions. We have found the domain of these problems many times this year, but now specifically we'll call them rational functions now. Okay, and then we're going to get into finding the vertical and horizontal asymptotes of the graphs of rational functions. That's as far as we'll get today. And as you can see, rational functions lend themselves to vertical asymptotes and horizontal asymptotes. This graph has both, and that's a graph of a rational function. Okay, what is a rational function? Here's the definition. It's actually a quotient or fraction of two polynomials. We just dealt with polynomials for like 4 or 5 sections. So a polynomial is quadratic, cubic, linear. So you could have something like this, where n of x is a quadratic, x squared, over a cubic. Okay, something like that. That's an example of rational functions made up of a polynomial on top, polynomial on the bottom. Okay, they're just stating the denominator cannot equal 0. Fits back in with the domain, right? We know that. All right, so vertical asymptotes, they always take on this form. X equals some number. Okay. We've expressed vertical lines sometimes, the axis of symmetry the same way. All right, so x equals a. Both sides, the graph is going to be approaching infinity or negative infinity. Take a look at that over here. There's a vertical asymptote over here right at x equals 0, it says. You can't really see the dashed line, but it's kind of right here. So from the right, this graph is heading towards positive infinity, and then to the left, it's approaching negative infinity. That's very common to see for these vertical asymptotes. All right. The line y equals b is a horizontal asymptote when x's approach infinity in either direction, but it's also converging on some number. So what do I mean by that? This one here also has a horizontal asymptote at y equals 0. So as this graph, as x is approaching positive infinity, it's getting larger and larger and larger in this direction. The y values are getting smaller and smaller and approaching y value of 0. Same thing going this way. Okay, it's getting closer and closer to it, but actually never touch it, which seems impossible, but you really think about how small numbers can be, I guess mathematically it makes sense, okay? All right, slant asymptotes are just that. They're also called oblique asymptotes. Sometimes they are going to be at a diagonal, all right? And so we describe a linear line or diagonal line using y equals mx plus b, of course. All right, so there's the form of your asymptotes. Slants in your equation, horizontal, y equals a number, vertical, x equals a number, okay? And it's demonstrated right there with the y equals 0. Maybe I should even highlight that. Y equals 0, okay, matches up there, and then vertical asymptote, x equals 0, and then we have the slant asymptote right there. Okay? There's also another VA right here, x equals -1, another example of that. All right, so here we go. Let's get into the examples. There's your introduction to rational functions. Find the domain. This is review. This should go pretty easy. All right, I just have 1 and 2 to go over. All right, we can probably look at this and just tell x cannot equal -6 because -6 plus 6 is 0. We can't divide by 0. So we say the domain is x cannot equal -6, or we could write an interval notation. Okay. All right, I was going to have you try 2, but I already have it here, so oh well, we'll just do it together. You might be able to just look at this as well, but if you can't, remember we set the denominator equal to 0, and then just try to solve it. So I'd use difference of 2 squares and say x plus 3 times x minus 3 equals 0, and then we can see the 2 zeros that are restrictions on the domain, okay? All right, this one will take a little bit longer to factor. Actually, yeah, there are factors of 2 that add up to 3, so we'd have to split the middle term and do that. But let's just wait for now. I think that's enough to review this. Let's move on to the next learning target, okay? Okay, on this page, now we're going to kind of break down how we specifically find vertical and horizontal asymptotes, okay? There's a lot here, so pay close attention, okay? And you may need to rewind this and review this. All right, so they're just showing us a polynomial function. I don't know why it kind of looks confusing, but this just means polynomial over polynomial, right? This is x to the, let's just say it's the 4th power. Then what's 4 minus 1? The 3rd power. So x to the 4th, x to the 3rd, plus all the way down to the constant term. Okay, so two polynomial functions where n of x and d of x have no common factors. This is key. You got to realize that what you need to do is eliminate common factors. If it says no common factors, it's your job to make sure you have simplified out the common factors. So I want you to make note here. This means, so we need to simplify first. Now those skills we did in section A.4 is what you're going to use right here. Simplify the rational function first, okay? After we do that, then we can move on to step 1. The graph will have vertical asymptotes at the zeros of the denominator. Zeros of the denominator. Well, that's just like finding the domain. We just answered a little bit differently, okay? So that's key too. It tells you exactly what you do here. Find the zeros of d of x. All right, since there's a lot to unpack here, let's just start with that, and then we'll go over horizontal asymptotes. So find all vertical and horizontal asymptotes of the graph of the function here. These, as you can see, these are all rational functions down here. Okay, so first of all, can we find any common factors and simplify them out? I can't here. Okay, this is already simplified. There are no common factors, so we'll make note that we at least checked. This is already simplified. Okay, so I can move on to the next step. No common factors. Okay, now we need to find the zeros of the denominator. Okay, so I need to take x minus 4, so zeros of d of x. All right, so x minus 4, we set equal to 0. We solve it. Obviously, this is going to be x equals 4. All right, so you just got to know the difference of the directions and how you answer this. Okay, on the previous problems, we said the domain is x cannot equal 4. And if it did say find the domain of this problem, we would say x cannot equal 4. All right, but it just so happens when we have these restrictions on the function, okay, there's going to be vertical asymptotes at that spot. So we kind of word it like this. There's a vertical asymptote at that spot of x equals 4. All right, so I'm going to say there's a VA, for short, you can abbreviate it as well, vertical asymptote at x equals 4, okay? Okay, now let's move on to the horizontal asymptote. The horizontal asymptote just has kind of 3 conditions we need to follow, and you'll get used to it. It looks like a lot, but you'll catch on quick, okay? All right, notice what it says is we're going to compare the degrees. Compare the degrees of n of x and d of x. So we're calling these n up top and m on the bottom. That is an important... All right, sorry, my dog knocked over the gates, of course. All right. Where was I? Okay, so yes, we got to look at these degrees. N is going to be the degree up top, m is going to be the degree in the bottom. All right, so right now for 4, if you look at n and m, the degree up top is 1 and the degree on the bottom is also 1. They're both linear. Okay, so when you look at these conditions, it says when n is less than m, the degree is not lower up top. It's this situation, right? The degrees are equal. So when the degrees are equal, the graph of f has the line y equals a sub n over b sub m. It's basically the ratio of the leading coefficients. It's easy. Where is a sub n and b of m? It's right here, okay? All you got to do is divide them, and you get the horizontal asymptote on when this condition is met. Okay, so there's a HA at y equals a sub n over b sub m. Why? Because n equals m right now. And I'm doing some note taking down here. Once you get used to this, you'll just get to the answer, right? So in this case, y will be equal to 3 over 1. There's the leading coefficients. That's it, okay? So there's a horizontal asymptote at y equals 3. All right? Okay, let's look at 5. 5 has a little different scenario. Should be able to pick up the pace a little bit with the vertical asymptotes now. Horizontal asymptotes, I still got to go through some things. All right, so common factors. Let's try to simplify this. On the bottom, I can factor this to x plus 1 times x minus 1 but it appears there's still no common factors. So again, it's already simplified. So what are the zeros of the denominator? At least factoring it allowed me to see the zeros a little bit easier. -1 plus 1 is 0, and 1 minus 1. Okay, so plus or minus 1. So remember, the VAs occur at the zeros of the denominator. We know what the zeros are now. So not a whole lot of work you really need to show. We should be able to see it. VA at x equals 1 and at x equals -1. It's probably best to break this up and not say plus or minus 1 because they're two separate lines. Eventually we'll be able to put all that together on a graph. Okay, so there's the VAs. What about this the horizontal asymptote? Okay, so look at the degrees of the numerator versus the denominator. So we have 1 up top, I have 2 on the bottom. So which scenario is this? Is n less than m, equal to m, or greater than m? It's definitely less than m. 1 is less than 2. So let's make note of that. N is less than m. Okay, this one's easy. Once you recognize that, it will always have an asymptote at y equals 0. That's it. All right, nothing to debate, nothing to calculate. That's it. You just got to memorize it. So when that happens, we simply say there's a HA at y equals 0. Done. Okay. All right. So let's keep moving on. I think you got enough to try 6. Why don't you try 6? Okay. See, and then I know we didn't go through this last scenario yet. We'll get there. Pause and try 6, okay? Okay, here we go. This one can be simplified. Up 4 and 5, we couldn't. Now, there are going to be some common factors for 6 and 7 that we can take care of. I can take a 2x out of the bottom, and then most of you probably can see this. X squared divided by x is just x on top. But if you can't see it, maybe you want to rewrite x squared as x times x, and then you can clearly see that we can simplify one of these x's. So now on top, I'm left with x times 1, and then 2 times x minus 2. Okay? Now it's time to find the VA, the zeros of the denominator. So I just take this, right, off to the side and go 2 times, you might want to distribute that to make it 2x minus 4 when you solve this linear equation. Okay, add the 4 and divide by 2. So I get x equals 2. What does that mean? I have a VA at x equals 2. All right, now here's a perfect example why you have to simplify. If you didn't simplify this ahead of time and you set this denominator equal to 0, you'd have 2 VAs. I'd have one at 2 if I use the zero product law, and then if I set 2x equal to 0, I get 0. And there's not 2 vertical asymptotes. There is 1. Okay, all right, and then the horizontal asymptote is at y equals what? The degrees are equal. So hopefully you realized, all right, they're equal. So now I need to find the leading coefficients right there, and I just divide them. That's it. And so I could jump right here, 2 over 2. So here's 1/2. That's the answer. Or you can even look at your simplified one. It's going to be the same. Okay, 1/2. Okay, let's try this again. Number 7. This actually has the degrees higher on top, which is a little different. Okay, it just means there's going to be no horizontal asymptote. All right, but you try the vertical asymptotes. Why don't you pause and try to simplify this first, and then we'll go over here in a minute. Go ahead. Okay, very important too. You don't forget to put either x equals or y equals. If you just put VA at 1, that's incorrect. You got to describe a vertical line, and having that x there makes that vertical, and this makes it horizontal. All right, so here we go. Here's 7. This factors like this on top and this on the bottom, and it does have a common factor. X plus 1's divide out, and we're left with this. Okay, so what are the zeros of the denominator? Should be easy to see now, right? -2 plus 2 is a 0, so there's a VA at x equals -2. Okay, horizontal asymptote. Like I said, when n is greater than m, that's what's happening here. N greater than m, all you got to say is there's no horizontal asymptote. So no HA. Okay. All right, we'll do the slant asymptotes in the next video.